we officially start Unit 4 today, which is all about lines and slope and graphing. So there's a lot in this unit, and we're going to ease into things today by talking about slope, but specifically, and it kind of means the same thing as slope, but we're talking about rates of change. Now, a rate of change allows you to see the relationship between two quantities that are changing. So for example, if like you're going to the movies, the more people that you bring with you, the more the cost is going to be. So as the number of people changes, your cost will change. So rate of change just shows how those things are related as they are changing. Now, there's a setup that we use to write the rate of change, and it's a fraction. So I'm going to get a big fraction line going. Rate of change is the change in y. So we got to talk math here. So there's going to be x's and y's, and it's how the y value is changing over how the x is changing. So we'll say change in x on the bottom. All right, so your rate of change is always going to be a fraction. How the y is changing on top, how the x is changing on bottom. Now, there's two things that I want you to note when you find the rate of change. You need to make sure to put labels, and we'll kind of show you in the examples what that means. You need to put labels on your answer and make sure that you always reduce your fraction. Okay, the labels help us make sense of what the answer means, and reducing it makes sure that we always get the same answer as the person next to us. If we always reduce it down. So there's three different scenarios that you're going to have to find the rate of change from, and the first one is from a table. And we've got two practice problems here. The first one is a table that relates the cost of a pizza to how many toppings you buy. So on the left-hand side, which I know that that's the x's in a table, and the cost is the y. On the left-hand side, though, they tell us how many toppings we're going to have, and the related cost is on the right. So if there's no toppings, it costs 10 bucks. If I add 2, it costs 14, 4 costs 18, so on and so forth. Now, to figure out your rate of change, you have to decide and determine how the y is changing and how the x is changing. Now, you only need to really look at two pairs. If this data is linear, which we'll talk about that word later, and during this entire unit, the data is going to be linear. If it's linear, you really only have to look at kind of two data points here. So if I look at how the y is changing, it's going up by $4, the cost is. And if I look at how the x is changing at the same time, it looks like that was going up by 2 toppings. So I'll say plus 2. If I make a fraction out of how those two numbers are changing, that's called a rate of change. And you guys, a lot of you could look at this probably and say, oh, the pizza costs 10 bucks, and here's how much each topping costs. But we can kind of use our rate of change here to make sense of that without being able to look at it right away. Ignore the bell. So how the y is changing, it's changing by 4, and the x is changing by 2. When they say put labels on it, they mean like whatever the table's talking about, put those same units, those same labels on your numbers. So it went up by $4, the cost did, every 2 toppings. So what the x was talking about. And then, like we said, you need to reduce this number, so I can divide both of these by 2, and that'd be 2 over 1. So my answer is $2 every 1 topping. That's my rate of change, and they're going to ask you a lot of times to explain it. Well, it's $2 every 1 topping, so I can see that each topping costs $2. And again, a lot of you maybe could look at the table and determine that, but there's kind of how you use rates of change to figure it out. The second example is a table that shows the height of a balloon in the air after someone lets it go. So I've got time for x and height for y. When the time hasn't even started, the balloon's 5 feet above the ground because someone's holding it in their hand. After 5 seconds, it's 25 feet, 10, it's 45, so on and so forth. I want to do the same thing to make sense of how these two quantities are changing. So I'm just going to look at the same first two pairs again, like I did on example 1. It looks like the y, the height, is changing. It's going up by 20, and the time is going up by 5. So I'm just going to make a fraction. 20 over 5. Get my labels on, so it was 20 feet every 5 seconds, which I know I can reduce. I can divide both by 5, which would be 4 over 1. So it's 4 feet every 1 second. So if I explain that in relation to the balloon, it looks like the balloon goes 4 feet, gets 4 feet higher every 1 second. So the balloon gets 4 feet higher every second. Cool. Okay, so that's tables. The second scenario is from a situation. They might give you a sentence and say, like, figure out the rate of change and explain what it means. So here's the situation for our example here. After 3 days, the farmer had collected 38 total eggs. And after 7 days, so I'm going to underline, after 7 days, he collected 194 eggs. I want to find the rate of change. So I basically want to explain, how does the number of eggs depend on the days? How are those things related? My suggestion, you guys, is make a table. Like on the first two examples, you have to figure out, is it days or is it eggs? That's the X. And the X is always dependent. So which one stands alone? And that's always the time. So I hope that you've heard those words before, probably in either math class or biology. But the X is always independent. Your Y, so in this case, that's the number of eggs. That's called the dependent variable. So the number of eggs depends on how many days the farmer is collecting. I'm going to make a table. So after 3 days, he's collected 38 eggs. After 7, he's collected 194. And now I'm going to do exactly what I did up here at the top. So let's see, what do you add there? Well, maybe you can't see that real clearly. What do I add to 38 to get 194? So do the opposite and subtract it. So the Y value went up by 156, and the X value went up by 4. So I do Y over X, get my labels, 156 eggs every 4 days. I want to see if I can reduce that, so I'm just going to divide it, see what happens. Oh, and that worked out perfectly to be 39. And to keep it a fraction, I'd put over 1. They didn't tell me to explain, but if they did, I would make sense of this by saying the farmer collects 39 eggs every day. The last case that you'll be asked to write a rate of change from is from a graph. So I want you to really make sure that you take note of the scale on these, on the X and Y axis. And what I mean by that is they aren't going to always be counting by 1. And that makes a huge difference, so please take note of what the scale is, what they're counting by. I'm going to suggest that you do the exact same thing, though, that we've been doing. That you make a table. On the x-axis, that's the weight. And on the y-axis, that's the cost. And we're talking about how much oregano costs. So we want to kind of write the rate of change. How does the price of oregano change depending on how many ounces I buy of oregano? If I were you, you need 2 points to get on your table. So I would find 2 points on your graph. Let's see, I see one right there where the line's going nicely through the corner. and I see one right there. I need to put these points on my table, so I'm going to figure out what ordered pairs these are. And it looks like this first one is the ordered pair 2, and then they go up. It looks like 1, but remember to take note of the scale. Going up 2 is actually 1, so halfway would be 50 cents. So it looks like for every 2 ounces, it's 50 cents. I'm going to say 0.5. And I'm going to put that point on my table. And then the second ordered pair is right 4, so 4 ounces costs $1. I'd make a table and I'd do the exact same thing. So the cost went up 50 cents and the weight went up 2 ounces. Make a fraction. So it's 50 over 2, get your labels, 50 cents over 2 ounces. And then reduce it. You can divide both of those by 2. So that would equal 25 cents over 1 ounce. And then if I had to explain, I would say each ounce of oregano costs 25 cents. All right, last example, we're going to do the exact same thing and make a table. And this time we're talking about how much gas is in our fuel tank. So it looks like the x-axis is the miles and the y-axis is the gallons. All right, I need to get 2 points on here. So I see one right here. And, ooh, the only other one I see is at the very beginning, at the top, which is totally okay to use. And I'm going to take note of the scale. This first point's a little bit easier to see. You don't go left and right. So I haven't driven any miles at all. And I've got 15 gallons in my tank. This point, though, okay, it looks like you go right, 1, 2, 3, but take note of the scale. Going right, 2 is actually 100. So halfway between that would be 50. They're counting by 50s. And let's go ahead and look at the y-axis. Going up 2 is actually 5. So 5 divided by 2 would be 250. And then this would be 750, 1250. So be really careful what they're counting by. So to get to this second point, they go right 150. And you've got, so if there are 150 miles driven, there's 5 gallons in the tank. Okay, let's figure out how these are changing. Okay, look at the gallons. We haven't seen this yet. It doesn't go up by 10, it goes down 10. So I'm going to say negative 10 because I'm subtracting. But the miles went up 150. When you write your rate of change, you have to use the negative value. And the x was positive. So it's negative 10 gallons over 150 miles. And let's reduce that. Simple way to reduce, if both numbers have a 0 at the end, just knock the zeros off. So negative 1 gallons over 15 miles is my rate of change. And when I explain that, I would say, okay, well, the gallons are going down because it's negative. So every 15 miles, the car drives, you're going to use 1 gallon of gas.